Hi guys, I'm going to be talking about second order linear differential equations. Let's get right to it. Okay, so let's start out by talking about second. Okay, it's a lot to type, so I'm going to not type it and tell you that we're talking about second order linear differential equations. So the form that they exist in is p of x y double dash plus q of x. I'm sorry for my terrible handwriting. I am clearly not good at this. Um, Plus r x y is equals to g of x. So I know it looks kind of intimidating and weird, but all this really means is that we're finding an equation, like a differential equation, which is basically like an equation that exists in the world for a function that can be written and expressed by its own like version of its differentials. Okay, I guess that sounds even more stupid, but what that means is that when you have a function y, you find the differential, like you differentiate it, you find y dash. You find another differential of that, which is like y double dash, and it actually maps on like these three functions together. They kind of create, like, help us find an accurate prediction for g of x. So in this, like, basically we can use the function and its differentials in order to like find other applications in the world. I guess that is still really stupid, but I guess you kind of need to learn this for school, so let's go ahead. So when g of x is equal to 0, when this is 0, it's called a homogeneous. That is the homogeneous case. And when it is not equal to 0, it is the non-homogeneous case. Non-hom. I hope that is good enough. Let's move on to the next slide. So as you saw, p, q, and r, they were functions, which was like really weird because like usually you just see like a number ahead of it, right, in your questions and stuff. But let's say if we take them as constants, like a constant is also a function, right? Again, that sounds really stupid, but I can prove it to you. Like, okay, here we go to Desmos, we can graph it. I put like y is equal to 5. So that is a constant function. You can see that, like, technically it's still a function. Okay, so now let's consider all of these are like constant functions. Okay, all right. So then we get the form, like you can express p as a, all right. Then you can express q as b, and then you can express r as c, and then since g of x is 0, we can just write 0 right there. Okay, um and usually to simplify this further, I know this looks kind of weird, like intimidating, y double dash, like what does that mean, like differential equations, you just pull that out of anywhere. Yeah, I have the same problem, but apparently if you find like a function that exists in real life, like let's say the speed of your car, we find its differential, which is y dash, and then we find its differential's differential, which is y double dash. So then apparently if you can create functions which give you like good answers of the real world, if you like are able to solve them together. So yeah, we're looking at the homogeneous case. Obviously it's kind of stupid, but it's just so we feel kind of comfortable to use them. I don't know if I'm making complete sense. I don't know if I understand it myself. I'm kind of rusty. This is my first video. I hope you guys like it. um okay, so this is gonna be ar square plus br plus c. um it's gonna be c and not cr because we're considering y dash to only be like to equal r. So like if there's like two dashes, then consider it r square because it's like just go with it for now. I mean, I think I kind of get the logic, but it's a little weird. So if there's just y, then only put the constant. However, if you just had c with no y over here, okay, you do not include that c. That c is only considered because we have a y there. So yeah, just go with this, and basically what they say is that the general, like, usually the answer that we get to these kinds of equations is y is equal to e raised to r of x. So if we find y dash, it'll be r e raised to r x, and then y double dash will be r square e raised to r x. All right, so imagine that we replace all the all the y's with this. All right, so then what we would get is like e raised to rx multiplied by this. You can do the computation, but basically what I've substituted in here is just like take this, put this instead of this, take this, put this instead of this, take this, put this instead of this, and then what you'll get is this. So then if you divide both the sides by e raised to r of x, what you're gonna end up with is ar square plus br plus c. So this is a regular quadratic equation, right? So we know how to solve this. So we will find r using the quadratic formula, which is minus b plus minus square root of b square minus 4ac divided by 2a. Okay, so I'll give you a few scenarios. In the scenario that b square minus 4ac is greater than 0, you will get two different r's, r1 and r2. I'll tell you why. So imagine if you get like a, an actual like legit number, like something that's greater than 0, like let's say 2, 3, 4, 5. So there are two scenarios in this case. You add that to, like so let's say it's square root of 4, right? So that is greater than 0. So what is square root of 4? It's 2. So you're gonna have to add 2 to minus b because it's plus minus. So you're gonna have so it'll be like whatever minus b is, and then you add 2 to that, and then whatever minus b is, and then you subtract to that. So that's two scenarios. So scenario 1, scenario 2, and that's why you get two solutions. You get it? So whatever answer you get here, right? Let's say it is I and j. I'm sorry, this is not the complex situation, this is just a random situation. So y will equal to e. So this is how it usually, like, you would write its solution. So it would be c1 e raised to r1 x plus c2 e raised to r2 x. And there you go. Let's figure out the next scenario where b square minus 4ac is equal to 0. In that case, right, our quadratic formula, it had plus minus and then it had something here, right? And if that something is actually 0, then it doesn't matter to us anymore, right? I'm sorry, it's kind of rude, but like it doesn't matter anymore, okay? So we'll only have one possible solution, which is minus b over 2a. So then the only, like, the format of this solution will be c1 e raised to rx plus c2 x e raised to r x, and in both cases the r will be the same. I mean, I think it's kind of stupid to write r1 and r2, but just imagine you will only find one r through this, so it's gonna be, you'll have to put it in this form and then you'll have to plug it in here, they'll be the same number. Alright, let's consider the last scenario now. So for the last scenario, square root of b square minus 4ac is less than 0. Okay, in the case that it is less than 0, basically it means that like minus b plus minus and then whatever this is, which is like the same as this, and then r2a, it's gonna be negative for sure, right? It's gonna be definitely negative, and the square root of like a negative number is always complex, right? We know that. So the answer that we're gonna get is in the complex format as well. So what we're gonna get is, we're gonna get two r's because it's a complex number. We're gonna get the complex conjugates, alpha plus beta I, and then r2, which is the second one, but it's pretty much the same thing. But since it's like this has a plus minus, like this will also have a plus minus. I don't know if that makes sense. If it doesn't, just go along with it and know that because this is negative, you will have a complex form, because the square root of anything that's negative, like square root of negative 1 is I, right? So imagine square root of anything is like basically square root of negative 1 times the square root of whatever number's inside. So it is going to be a complex number, that is for sure. And because this gives us like the b, the complex side of it, it'll look like this, like, you know, it'll have a conjugate. And the way we'll write the solution is y is equals to e raised to alpha x, and then c1, I don't know how Euler came up with this, but basically if you find the alpha and beta, you can write it in terms of like Euler's number e or whatever. That's what he says. So if he says it, I'm gonna listen to him and respect his wishes and write in this form, plus c2 sine I know this looks a bit confusing, but if you think about it, these are the three scenarios that can exist, and now you know all of them. Thanks.